Okay, so I got this working now at least. Let's go here. Okay, there we go. Let's pull up this so I can see it. While I'm presenting. Okay, that'll work. All right. Let's get started. Hi, everyone. My name is Alex Hodges, and today, let me fix this camera real quick. There we go. Hi, everyone. My name is Alex Hodges, and today I'll be going over my ICTN 4020 and 4022 project, which also stood as my signature honors project for this year. This is kind of my final project for my ICTN degree and for the senior honors project. So today I'm going to go over 3 different portions of it. I'm going to go over just a project overview. I'm going to do a brief preview of what the lesson actually looks like, and I'm going to finish with a brief preview of what the hands-on activities look like. So we will start with the project overview. The contents of this presentation are going to include the project description, the project background, the scope, the duration of the project, the process and creation of the project, successes and difficulties, lessons learned from the project, future improvements, and the conclusion. To begin, we'll start with the project description. And the project description just kind of goes over what the project was about. This project was to create a lesson, or in this case, a series of lessons, to explore wireless networks and protocols. The lessons were targeted towards high school students, and the intended outcome was to spark interest in the IT field. To accomplish this goal, many lessons were created, and each featured creative, interactive components, and these were created to be audience appropriate and to initiate curiosity in the field. So now we're going to go a little bit more in depth from the description and explore the background. So this project kind of came about to address a couple key concerns, just based on our previous experience in high school and looking at STEM classes. We realized that the lack of information and education, specifically about the IT field, especially in the local area, is kind of concerning, especially knowing how important IT is now, and to a more specific degree, wireless. With the pandemic and everything being moved virtual, wireless and IT is becoming more and more influential in our daily lives. So we wanted to create a series of lessons that encourages enrollment in IT programs or career exploration. And the education that I received from East Carolina University, as well as hands-on experience from my jobs, provided a great knowledge base that we could kind of build off of and address, what's important in the workforce and incorporate those into the lessons and the hands-on activities. So this project was started based on an identified need. And the need, again, is to encourage more high school students to explore the IT field, particularly wireless. We found that a lot of IT education in schools currently focuses on wired networks. And while that is important, especially because that allows you to get a greater understanding of the basics of all networks, the emphasis on wireless needs to increase because that's the new norm, right? When you go to somewhere, you don't plug in, you pop open your laptop, you put in the Wi-Fi network ID, the password, and you're good to go. So we wanted to create lessons that kind of could build off of that and provide a better education there. So this project is needed because it provides a benefit to the audience, the high schoolers, the schools, the job, and the university. For East Carolina University specifically, it will encourage enrollment, especially since we focused on local schools and local areas who may have less resources than other schools. It also encourages new talent to enter and explore the IT field, which could increase the workforce. And an increase in the workforce could, in theory, lead to an increase in or an improvement in the economy. It also offers guidelines for STEM education in schools. So these lessons not only stand by themselves, but they can be used as an outline or a baseline to build other STEM lessons and IT lessons off of. Finally, we wanted to simply provide education to the students, kind of get their knowledge growing in the field, and of course with that, their interest. So now we'll discuss the project scope a little bit, kind of identify what the project is and what it isn't. Excuse me. So the goals of the project were to encourage students to explore and consider the IT industry, and this is both in the workforce and in school, as well as inform students on various IT topics. In this case, it was specifically wireless. And for us, the goal was to develop presentation and project management and creation skills. The project had three major deliverables throughout the course of the project. Those were the lessons, the hands-on activities and content, and actually presenting these lessons. The lesson presentations were supposed to be done live originally, but they ended up having to be moved to a video format because of the pandemic, and that kind of threw a wrench in the whole thing. But we may do, and I have one of those videos, or actually two videos, one for hands-on activities for lesson one, and one for the lesson slides of lesson one, up on my YouTube page if you want to look at those. So the project boundaries, this is kind of establishing what the project doesn't cover, with the students having limited time and resources to devote to these lessons. We wanted to make sure that we cover the important things and leave the less important things for later. So the boundaries were established to keep the scope targeted and direct. And the boundaries specifically state that we will discuss and prepare presentations that revolve solely around wireless concepts. We didn't want to bring in too much because bringing up too much detail creates confusion and disinterest in the lesson, but also having lessons that don't have any new information and bore the audience and again create disinterest. So for the duration, the project lasted 2 semesters. It lasted last semester and this semester, and it was an ongoing project full of a lot of revision, a lot of editing, coming back to previous steps, revising, going forward, and a lot of testing. So, but with that in mind, there was 3 particular phases. It's important to note that these phases don't necessarily go in order. We started at 1, we moved to 2, and we may have had to move back to 1, or go to 3 and then move back to 2, or even 1. And it kind of jumped all over the place, but that's just the process of a reiterative project. So the phases that we had was phase 1, the planning phase. This is where you sit down, you identify what the need is, why that's the need, what the scope is, how you're going to approach it, build an outline, that kind of thing. In phase 2, we created the projects, we assessed the projects, and we revised them. Phase 3, we actually presented the projects and began execution, where we would test the lessons, test the hands-on activities, and kind of see their effectiveness and see where things need to be changed. We go back and revise them and continue the process. Within this process, there were a few major milestones we knew we had to hit, and this helped us schedule out the project. The first one was the planning and authorization. Before you can begin a project, you have to have a good plan of kind of where you're going, how you're going to get there, what needs to be done, and finishing that plan and getting it authorized was the first step. The second step, of course, was completing the actual project. By completing it, then it's ready for assessment and revision. And the assessment and revision process is ongoing. You're constantly going back and looking at it and saying, maybe I should add something here or take something away there or change something. So it's important to note that these milestones kept us on track to finish the project by the due date, but it doesn't necessarily mean that they're over. We're always going to go back and re-update something or see what can be changed, that kind of thing. So then the next milestone is revision complete, ready for presentation, execution, and further revision. And if you note there, I also have further revision. So again, that reiterates that it's a constant process. The final milestone was presentation and finalization of the project, which finalization is a rough word. Finalization is it's at a point that we feel comfortable that it will create the benefit that we need to create. It may not be perfect. There may be things that need to be changed, but that's where we're at with it now. So next we're going to talk about the project process. This is the step-by-step how we got to where we are. Let's get to the slide. There you go. So the first step in the process was to select a topic. In this case, we selected wireless networks and protocols. And this topic was selected based on the comfort level and knowledge of the team members. We were eager to share our current knowledge, but also develop additional knowledge. And also this topic was selected because the networking education, as I've said previously, in high schools often focuses on wired networks with just a mention or two here of wireless networks, where we really wanted to not take away the attention from wired because wired networks create a great foundation, but we wanted to add on that, there's also wireless networks and what benefits they bring and address those and make sure that they're educated on those because that's becoming the new norm. Additionally, students are familiar with wireless networks. They're on their mobile devices all day. So that familiarity creates an interest in the students. Next, we're going to move on to lesson selection. And this is where we decided what topics we were actually going to talk about. In this case, we decided to talk about wireless networking as a whole. This is kind of a general overview of what wireless networking is. And then we get more in depth. We do wireless security, mobile devices, mobile computing and applications, and finally wearables. These lessons were selected for several reasons. Number one, we wanted to cover key topics in the wireless networking field. And these topics are important for both creating interest in career fields and, they're important in career fields, but then they're also important for generating interest in the career fields. Additionally, these topics address several North Carolina education standards. The North Carolina education standards that they address we'll go over in a few slides. The lesson structure is also built to build on each other. So lesson 1 gives you a base understanding, and lesson 2, wireless security, adds on to that base understanding by saying, okay, so now you understand what a wireless network is, how to set up a small one. Now, how do you secure the small one? And from there, we delve down into more specific devices. So we delve into mobile devices, students may be more familiar with. And from there, it also creates a benefit to being able to take knowledge from previous lessons and apply it to later lessons. So for example, for the wearable devices lesson, one of the activities we have them do is identify where we think wearable devices will be in the future, what problems we think they'll address, and how we think they'll communicate. Finally, the last bullet point is kind of a reiteration of an earlier one. It allows for the exploration of many areas and career paths. Next is lesson planning. This kind of just goes over how we structured our lessons. There were 5 total lessons, and each lesson consisted of slides with a script, as well as instructor notes. And these are so the instructor can present them in person if need be. But the slide presentations were also recorded, and that was a change that we made to better accommodate virtual learning and learning at your own pace. If the instructor has to present it live, then everybody's held back to, when the instructor can do it. Whereas if you have a recorded video, you can go at your own pace, rewind, fast forward, and cover things that you may have missed. Slide review questions were also built in. These are to check the students' knowledge, make sure they're getting the key points out of the lesson that they need to get. With each lesson also came 3 hands-on activities, and these also have instructor notes for the purpose of being taught live. Each hands-on activity is about 20 minutes each, and they employ various teaching methods to ensure maximum learning capability. So basically what that means is we have various teaching methods employed in the lessons or in the activities, and that's ranging from audio from the recordings to video from the recordings to research-based to reading and collaboration. Even there's some collaboration questions. So that's kind of what we mean when we say they employ a multitude of teaching methods so that the maximum number of students can get the most out of it. Just like the lessons, there are review questions built in to check the knowledge and make sure they're pulling key takeaways from it. And the hands-on activities were also recorded. So these next few slides just go over a brief example of what a lesson typically looks like. We'll be using lesson 1 as an example, and lesson 1 can also be found. The video that kind of goes through the lesson and the activities can be found on my YouTube page. So lesson 1, for example, covers North Carolina Educational Standards IST NC.DLS EL1A, EL1C, and KC3A, as well as NC CET1 2.05, 2.07, and 2.09. I didn't write out exactly what these were just because it would clutter the slide, but those can be found online. They can be found in some documents posted on the Google Drive. There's a multitude of places that those can be found. Next in the lesson, you would cover your learning objectives. So for lesson 1, the learning objectives established were to define a wireless network and its benefits, compare and contrast a wireless and wired network to identify advantages and disadvantages of each, as well as determine when each should be used or when each is preferred. Identify types of wireless networks, their benefits and differences, and when they are used. Choose a model that is most appropriate for a given straightforward scenario. And finally, match common wireless protocols and standards with their uses. Next, we would go into we would actually go into the lessons. In this case, instead of posting all the content, I just go over the topics that we selected to cover in lesson 1. In lesson 1, we covered what is a wireless network, wireless versus wired networks, common wireless types and security protocols / encryptions, common wireless network protocols, included with a summary and a lesson review. It's important to note that each topic and each section is ended with a lesson or a section review to go over what was covered in that section, make sure they get the most out of it, the key takeaways. Next, we'll go over the hands-on activity content example, and this is much the same as the previous few slides. It covers kind of what the general outline of the hands-on activities would look like. So each of the hands-on activities consists of the following sections: the title, the learning objective, the background, the setup, instructions, and review questions. So you'll have 3 hands-on activities, and each hands-on activity will include this. So if there was 5 lessons for a total of 15. Lesson content creation. This slide just tells you the content was created over several months with constant revision and editing. And then it provides you a few links of where you can find the content at. For right now, lesson 1 is the only one provided, but we hope to increase that so that all 5 lessons are provided shortly. So now, after we've gone over a brief overview of what the project actually was, I want to talk about some of the successes and difficulties I faced with this project. So there were a few successes that I want to make particular note of. These include quick and meticulous project planning. The planning phase was relatively short. We had to go back to it every so often, just when revisions took place. But overall, it was pretty short. But in that short amount of time, we were able to get a lot of detail down and a lot of understanding of, okay, this is our goal. This is the objectives we're trying to reach. This is our plan to get there. This is the outline for what the lessons are going to look like. And we had it down in a very clear structure so that it could easily be followed in most cases. The other successes I want to mention, or another success I want to mention, is that we definitely accomplished our goals, I think. The benefits that schools and students will receive from these lessons it's phenomenal. It's not, and that's not to say these lessons are anything revolutionary. They're overall pretty basic, but providing that basic knowledge, that basic understanding, is what drives students to want to learn more and drives students to want to explore the field. So that's really what our goal was, and I'd have to say that I think we accomplished that pretty well. Another success that I found that we had was their ability to remain flexible with COVID coming up and the pandemic coming up, and so many schedules having to be changed, different priorities, different commitments, and structure and even the structure of the project itself being changed. We were able to remain flexible enough that we could pivot and kind of go in that direction. It wasn't always easy. There were definitely some places where there were some setbacks, but I think the ability for us to pivot and remain flexible and open-minded was important. The next success is the applicability of these lessons. The lessons are definitely applicable to today's students. They cover topics that they find more familiarity with. They are applicable to the world we live in now with the pandemic and home networks and wireless having to be so widely used now. It's definitely applicable to today's world. The videos that we produced were also very well done. They're not professional by any means, but for the resources that we had, they look great, they cover the information, they sound great, and they're definitely beneficial. And that actually goes into the last point. It's beneficial to all stakeholders. Everybody involved in this project will benefit, even from the creators who benefited from learning lessons along the way, learning how to prioritize project manage, that kind of thing, to the students who will get education and spark interest, to the schools who now have a baseline and some lessons to kind of build off of, to the university who will, if they notice that ECU students make this, they'll say, oh, maybe we should go check out ECU. Maybe we should consider going through their IT program or consider going to their college for some other reason. So everybody involved in this project had something to gain, and I think that's definitely a success. So now let's go over some difficulties. While this project was overall successful, there was definitely a lot of difficulties along the way, and I want to go over a couple of the biggest ones that I found. Number one, plans can't cover every scenario. You're always going to have things come up that you didn't plan for, that you can't plan for. And one of those was the rapid shift to a virtual environment. And this forced quick project adjustment that created some hiccups along the way. As I said, we were originally planning for this project to be organization-based, so we would approach an organization, work with them on an IT infrastructure project and go that way. And then it was adjusted to be lessons-based, so we would create lessons that cover a specific topic. And then from there, it's actually shifted a little bit more, saying instead of presenting live, you would have to present virtually. So the rapid shifting in not just the project structure, but in people's schedules and commitments and priorities, that made planning difficult. It made expectations evolve quickly, and as such, it made those expectations unclear at points. And it also limited I'm going to skip down some. It also limited to the interaction that we could have with partners and team members and other people that, maybe stakeholders in this project. We couldn't meet them in person, so we had to meet them online, if at all. Sometimes it would just be chatting. And it really, I'm glad that we overcame the difficulties, but it was definitely difficult at times. Another thing that we found difficulty in is the recorded lessons rather than live lessons prevented feedback, response, and questions. So when you're presenting live, you get instant feedback, instant response. And when the lessons are recorded, you have to rely on the people that are viewing these lessons to leave comments, to ask questions, to reach out to you and provide feedback. And we found that not being in person prevents that feedback from getting to you more. If there's no incentive for them to comment, no incentive for the feedback to be given, there's likely to be less given. Finally, another difficulty was it was definitely a new experience. Virtual presentations and virtual projects even are something that I'm not super familiar with. So it was definitely a new experience, but it was one that I've learned from a lot. And that learning is from, learning how to schedule, time manage, plan, to learning how to deal with people with various commitments, various priorities, various ideas on expectations, that kind of thing. So I want to go over a couple of the lessons I learned during the course of this project. One of the lessons is the importance of communication. If it wasn't for good communication, this project wouldn't have gone anywhere. The communication had to be in place and it had to be set, because being virtual, you don't know when you'll see these people again. It's all kind of get back to me when you can. We had meetings set up oftentimes with the team members, but if other commitments come up, they may have had to cancel or say, I can't make it. So the importance of communication is definitely reinforced in this project, as is the importance of planning. As I said earlier, our project planning was very meticulous, and if it hadn't been so, it would have kind of left us out to dry. The project planning was very, this is how we're going to do it, this is what we're trying to accomplish, this is what everything should look like, and that created a workflow that was very clear to follow, very understandable, very easy to follow. And without that, I think the project definitely could have suffered. And that actually ties into my next point, is the importance of an established workflow, the importance of knowing what to do, when to do it, what's next, preparing, and the importance of preparing for those steps is definitely reinforced. I've already touched on this a little bit, but the importance of flexibility and coping with changing priorities and commitments, that's definitely important, as is the importance of self and constructive criticism. If it wasn't for the self-criticism, I don't know kind of what the standard of the project would have been, but I also don't know what would need to be improved. By being, as I've said earlier, by being virtual, you kind of miss out on some of the criticism from other people. So being able to criticize yourself and your own work, not in a way that's, beating yourself down, but in a way that you say, okay, maybe this could be better, maybe that could be better, is important. But possibly more important is the ability to take constructive criticism and incorporate that into the project where you can. Because the people that are giving you constructive criticism genuinely have, something to say about it, and genuinely want the project to improve. Finally, the last lesson that I really learned was the importance of defining a problem clearly. If it wasn't for defining a problem clearly, a lot of times we wouldn't know where to go. We wouldn't know what needs to be changed in the project. We wouldn't know what the project needs to address. We wouldn't know, are we addressing a symptom or are we addressing the root problem? So being able to break through all the levels and identify where the problem is and how it needs to be addressed, that's something that is important. And all of these lessons are going to be used, in the workforce, regardless on what industry you're in. So now I want to go over a few of the future improvements that we want to make to the project. And this will be broken up into 3 sections: documents and videos, modules and lesson planning, and then finally personal improvements. So for the document and video improvements, definitely I think increasing the editing increasing the quality of the editing to increase visual appeal and professionalism. That would attract a larger audience. Excuse me. That would attract a larger audience, and just overall create a better looking project, a better feeling project. Our project definitely is professional looking. It looks good, but there's always improvements to be made. One of the biggest improvements, I think, is increasing the detail depth on certain content. When you compare one lesson to another, you really notice that some lessons go much more in detail than others, and some lessons have a better explanation than others, and it's not super consistent all the time. And that ties into the third point of improving quality and consistency. So improving quality and consistency would overall make the project more cohesive. It would make the project more professional. It would make the project look better, sound better, be more educational and informational. And all of that ties back into, the increasing quality and increasing consistency. It ties back into establishing clearer requirements and expectations. The requirements were pretty clear, but what really needs to be addressed is the expectations. So, when some people see requirements, they see minimum. And when other people see requirements, they see, I need to address this requirement, but I need to do so in a way that fully addresses it rather than, the minimum addressing of it. So being able to establish those clear requirements and expectations, especially the expectations part, is definitely something that needs to be improved. And in doing so, you would increase consistency and quality. With working with multiple people, everybody's going to have a little bit of a different expectation, and that's okay. Not everybody has to think the same way, but understanding kind of an ideal level of expectation or a minimum expectation, that's really where I think we could have improved on. We set the requirements, but we didn't set a level of expectation. So that's really where that needs to improve. Finally, and this is a minor one, is improved document management. A lot of the documents for this project were kind of stored all over the place, and they were kind of stored all over the place, and combining those all into one central location would allow for a more efficient project to be finished more efficiently and effectively. Excuse me for a moment. I'm going to get a sip of water. So going into module and lesson planning next, it would have been beneficial to establish a more consistent and kind of rigid schedule. Our schedule had to move around a lot for various reasons, and that's to be expected, especially when you're virtual and other people have, so many other commitments and priorities. But having a more set in stone schedule that doesn't move around as much, it needs to be able to be flexible to incorporate people's priorities and commitments, but it also needs to not be so flexible that one day you just completely disregard the calendar. I think having a more consistent and set schedule that is more rigid, that doesn't allow for as much wiggle room, would definitely create a more effective team. The second point goes back to one made on the previous slide of establishing clearer and measurable standards. And I think the key word here is measurable. There's no real way to measure an expectation, to measure a quality standard, except for putting numbers to it. But numbers are kind of arbitrary. If you say, you should have 250 words for this particular part, it may not need 250 words. So finding a way to measure quality standards and expectations, I think, is really where the improvement needs to be made, and that's difficult to do. So in the future, I think that's what we're going to focus on, is being able to address and find a way to measure the standards that everybody's comfortable with and everybody thinks it's fair. The next bullet point is lesson division. So basically, this point says that had we divided the lessons up differently or combined lessons even in certain ways, we probably could have covered more topics, more maybe covered more career paths, all that sort of stuff. So I think ensuring that we have the optimal division is definitely an improvement that needs to be made. Finally, the last improvement that I want to make for the module and lesson planning section is to increase career prospect discussion. A lot of the career prospect discussion that we had was somewhat implied. There wasn't a lot of direct references to it. So I think that increasing that career prospect discussion would increase interest and kind of show students where they can go with a job or college degree in IT or even specifically networking or wireless. I think that overall we need to do a better job at talking about specifically career prospects that are associated with a specific topic. Finally, a few personal improvements I know I could have made. Number one, improving collaboration. A lot of the time, I would take on a task and hammer it out until it was done by myself. Um, not really, not really incorporate many other people, many other partners or mentors or outside sources into the project. And that's definitely something I could improve on is making sure that I reach out to more people. And that's not even for help. Reach out to more people for more ideas, for better ideas. Reach out for more people for input. So I think improving collaboration is something I can definitely work on. Also, the virtual structure made scheduling and planning difficult. So finding a way for me to cope with the constantly changing schedule it's necessary, especially if virtual is going to be a part of our lives for an extended period of time. Being able to cope with a constantly changing schedule and learn how to work around it, it it's going to be important in the workforce and in personal life. The communication improvements combines with the collaboration improvements. The communication needs to be more regular rather than sporadic. There would often be times where um, I wouldn't send many messages until a few days before we were reaching a milestone, or vice versa. I wouldn't receive many messages until a few days before we hit a milestone. So increasing the consistency of communication and maybe having a check-in every once in a while, or maybe at least saying something as like, anybody got a status update or anybody have any concerns, saying something like that, and even just in a chat would definitely increase the communication and increase team camaraderie, increase efficiency, all of that. Finally, the last improvement that I can make personally is to align priorities. And this is both with myself and with team members. Aligning my priorities with team members would allow for an increased accountability and efficiency and effectiveness with the team. But aligning my priorities within, what I have to do would also lead to an increased accountability and an increased efficiency because I would know, okay, this has to get done first, and then I have X more amount of time to do this, to do that, rather than and not only what has to be done first, but what's most important to get done. So a lot of times I structure things on what's due when, but through this project I was really able to learn that it's almost more important to structure it. Yeah, you have to keep the due dates in mind, but it's almost more important to structure it on what's the most important thing. So that was definitely something I learned through this project and definitely something I look to improve on in the future. So finally, a little brief conclusion about the project overview. The project taught lessons and knowledge to both the students and the creators of the project. It also helped us develop our soft skills, which are applicable in any field, my apologies. And this includes presentation skills, project management skills, collaboration skills, communication skills. All of those skills were developed or reinforced through this project, and those are skills that are constantly evolving, constantly improving. So that's definitely something that you can carry into any field. The next part of the conclusion just says that this project was able to benefit all the stakeholders involved. It benefited us, it benefited the community, the schools, the students, the university, and hopefully by allowing these lessons to be released freely, hopefully they'll extend beyond and benefit others. And my biggest personal takeaway for this project is learning how to work effectively with partners and commitments that have various priorities and expectations of the project. On any team, you're going to have people that have different commitments, different priorities, different expectations, and being able to cope with not only their ideas and expectations that differ from yours, but being able to align yourself with the group it's important. And the main thing here that I want to stress is the expectations part. Every group is going to have members that have a little bit of a different expectation. They may say, oh, this is good enough, or oh, this is not good enough. And being able to sit down and discuss what actually is needed and what actually is good enough and what actually isn't, that's something that I'll take away from this project as vastly important. So that concludes this presentation. I'm going to open up the YouTube chat now. So if anybody has any questions or comments, please let me know. I'm going to try to open up the YouTube. Comments. Your mic is really hot. Okay. Thank you. Yeah, it's a little loud. I'm not sure how to adjust it. This is totally new. So. All right, I'm going to pull up the next presentation while I'm waiting. And if anybody has any comments, feel free to leave them in the presentation, or in the if anybody has any questions, feel free to leave them in the chat box. Okay. All right. So I don't see any questions. Again, if anybody has any questions, leave them in the chat, and I'll get to them as soon as I see them. But in the meantime, now that I've gone over a brief overview of what the project is, I want to give you guys an example of what the project actually ended up looking like. So this is this slide deck is the set of slides that was actually recorded and provided to the students. So I'm gonna run through these really quickly. There's a lot of slides in the slide deck, so it's going to take a little bit, and I'm going to run through them quickly. Not in depth or anything, just kind of give you an overview of what they look like. So this is lesson 1 of our module, Wireless Networks and Mobile Computing. And the learning objectives for this module, as I've already discussed, are to define a wireless network, compare and contrast wireless and wired networks, and identify when each should be used, identify types of wireless networks and their benefits and when they should be used, choose a model that is most appropriate for a given scenario, and match common wireless protocols and standards with their uses. So first, before we can actually go into wireless networks, it's important to define what a wireless network is. So a wireless network is a network where connections are made that require no cables, and the devices communicate using radio waves. Next, let's go through a brief history of wireless networks. The full history of wireless networks is very long and complicated, so I just pulled out a few key points. In 1896, one of the key points was the invention of the wireless telegraph by Guglielmo Marconi, and this was one of the first forms of wireless communication. In 1946, the first commercial telephone service was invented. And in 1947 came the invention of transistors, in leading us to where we are today with wireless technology. The transistor allowed computing devices and technology devices to become significantly smaller in size over time. Previously, wireless devices and wireless phones were large enough that you couldn't actually carry them anywhere. They had to be in your car or in a briefcase. But over time, as the transistor became developed and more mature, they were able to decrease in size. In 1962, the first communication satellite was launched. In 1968 came the development of ARPANET. ARPANET went on to be a precursor of the internet. ARPANET was created for the military to send wireless communications. And in 1978, it was followed up with AlohaNet. AlohaNet introduced a lot of the wireless protocols and models that are still used today. And it was created by a Hawaiian university to communicate wirelessly across various Hawaiian islands. In 1979, the first commercial automated cellular network was released, and this was considered the first G or 1G of cellular networks. After this, we just saw continuous improvements in wireless networks and wireless offerings. In 1986, for example, came the first commercially available wireless network, which was called WaveLAN by NCR. In 1991, the 2G cellular network was released. And in 1997, the 802.11 Wi-Fi protocol was first released. This is the Wi-Fi protocol that's still used today, but it's been improved over time. So 802.11 was the original, but over time we've increased to 802.11G and various other letters. In 2001, the 3G cellular network was released, and in 2007, 4G/LTE cellular networks were released. In 2018, 5G cellular networks were debuted at the Olympics. So where are wireless networks used? Wireless networks can be used, in theory, anywhere that a wire network is used. Often they're used in public locations and open spaces that maybe you can't run wires to, or it would be impractical to do so. And these include cafes, hotels, offices, homes, libraries, and any place that advertises a hotspot. A lot of the hardware used in wireless networks is similar to what's used in wired networks. These include a wireless capable router. They have to be wireless capable in order to send and receive radio waves. Wireless adapters, and wireless adapters are devices that you plug into another device to allow it to use wireless. An example of this is a wireless NIC. This would be an example of one that you could plug into a computer or a laptop. And originally they had antennas so they could send and receive radio waves. Also, you need some form of wire-based backbone for connections to the internet and to the overall network. Access points and wireless extenders. These are both ways that the Wi-Fi network can be extended, and we'll go over in a slide or two the difference between these two. We also have switches, which are used in wired networks as well. Other wireless-enabled devices, wireless LAN controllers, and a firewall. So how do wireless networks work? First, the wireless adapters in devices send and receive radio waves. Sent radio waves are sent to the wireless router, which has a wired connection to the LAN and/or out to the internet. These radio waves are converted into machine-readable binary. Wireless access points amplify the signal by connecting directly via a cable to the router, therefore extending the range. Extenders and antennas work to amplify the signal by rebroadcasting the signal, so it'll pick up the signal and then rebroadcast it. So this is a little diagram of a wireless network, and let's say the laptop was sending a message to the desktop via wireless. It would send it to the router, and let's say it was sending it through the internet, for example. The laptop would send a message to the router, which would then send it to the modem, and then to the internet, and the internet would do the processing, and it would go back to the modem, back to the router, and out to the desktop. And then for the reply, it would follow the opposite order. So how do you connect to a wireless network? Connecting to a wireless network is pretty straightforward. Everybody's done it. You only need a wireless connection or a hotspot or something similar, and an adapter to pick up the signal. If the adapter isn't on board, which in most cases for a wireless device or a mobile device it is. Again, this is an example of the quick check that I was talking about that are built into the lessons. This one asked, how do wireless networks communicate? And it's a simple multiple choice question where the answer is highlighted at the end with a brief explanation. I'm going to skip the quick checks just because I don't expect you guys to sit there and answer questions, but I just wanted to give you a look at what they look like. Let me check the chat real quick, make sure there's been no questions so far. No questions so far. So next is a brief overview comparing wireless and wired networks. Wireless networks have a few advantages, including the installation speed and simplicity, the cost, the increased mobility and flexibility, wider access, meaning you can typically work farther away from a particular device, and many connections, as well as no wires. Other advantages include scalability, enabling bring your own device, convenience, and ease of use. Wired, though, has other advantages. These include more control. By directly controlling who plugs in, you have more control over the devices themselves and who's on your network. More secure, again, by having to directly plug in, it's less likely that someone can jump on your network. More reliable, better speed. More reliable and better speed. These both relate to interference that wireless networks can come across. Because wireless networks are radio waves and they have to pass through materials to reach your device, it's very likely that they'll encounter some interference of some sort, and therefore speed can be a problem, latency can be a problem, dropped frames or dropped packets can be a problem. So overall, wired networks are more reliable and typically provide better speeds. However, wireless networks are catching up quickly. There's a lot of top tier wireless networks that have similar speeds and similar reliability to wired networks. But the fact of the matter is, overall, wired networks are typically going to be more reliable and have better speeds. Disadvantages of a wireless network include interference and signal strength / quality. This goes along with the previous point. As you get further away from the wireless router or access point as well, you're going to have less signal strength and therefore probably lower quality, lower speed. Again, wireless is less secure. Anybody can hop onto your wireless network without having to run a cable to a device. Speed, wireless can sometimes be slower than wired in given scenarios. And dependability / reliable, again, depending on the given scenario, what it has to pass through, it can be less reliable and dependable. Wired networks have a few advantages as well. They are typically more expensive. That's not always true, but sometimes they're more expensive. There's a larger maintenance overhead simply because you have a lot of cables you have to deal with. If one cable goes bad, it can be difficult to find that particular cable and replace it, or trace the cable to identify where it's going. The cables can also be hazardous. They create a tripping hazard, for example. Additionally, with a wired network, you're limited to the number of connections, and with wireless networks, you're typically limited as well. But with wired networks, you're specifically limited to the number of ports available. Wireless networks, it's usually far less limited, if limited at all in most cases. In most cases, it has some form of theoretical limit, but yeah. But in wired, you're limited specifically to the number of ports available. Also, you have limited mobility because you have to be plugged in. You can't, go to a different room that doesn't have a plug or that kind of thing. You have to stay somewhere where you have access to a port. Again, some quick checks. We're going to zoom past those. And now we're going to cover a few common wireless network types and security protocols / encryptions. And these are going to go from smallest to largest, except for the last two. Last two are kind of unique. So the first one I want to cover is wireless personal area networks. These are a short range network of about 30 feet, and they're used to connect smaller items to typically a central location. This typically uses Bluetooth or a similar protocol such as IEEE 802.15, or they can use Zigbee, etc. Wireless local area network, these are typically one of the most common wireless networks. They have a limited exposure area. Usually they cover one building or a small group of buildings, and they typically use the Wi-Fi standard. Next, we have the wireless metropolitan area network. This typically covers a city or related region. It typically spans up to 30 miles, and it's commonly used in schools and colleges, as well as public services, anything that may have to cover a large area. Finally, you have the wireless wide area network. These are long distance wireless networks. They can be used to connect several smaller networks from around the globe and can be used to connect a company's headquarters, branch offices, cloud, and other facilities. This one's one of the unique ones. It's an ad hoc network. This is a LAN network that's typically created as needed. And they forward packets to and from each other without a central base station. They're commonly used when internet connectivity or Wi-Fi is not needed or available, such as in disaster relief scenarios. And this image over here is a brief image that shows what an ad hoc network may look like. So you would have the phone communicating to the laptop, to the other laptop, to the printer, that kind of thing. A hybrid network is a network that combines elements of multiple networks and technologies. For example, it may use both Ethernet and Wi-Fi standards. Now we're going to cover a couple of common security and encryption methods. This is where a lot of technical jargon comes into play, and I don't expect high school students to know this, but part of it is included in order to encourage interest, in order to encourage going out and Googling something or asking questions. So the first one I want to cover is wired equivalent privacy. This is the first security solution for wireless that was standardized, and it employed a 40-bit key encryption using the reverse cipher 4 algorithm and a 20-bit initialization vector. It was designed to bring wired security to wireless networks. And this is a brief example of WEP encryption. Next one I want to cover is wireless protected access, WPA. This was designed to be a temporary replacement for WEP that allowed for the use of 802.1x standards and other enhancements. 802.1x Extensible Authentication Protocol, EAP, was a layer 2 process which enabled a wireless client to authenticate to a network. Layer 2 is a MAC address. Layer 2 is physical addresses. They communicate physically rather than level 3 addresses, which are logical addresses, IP addresses. Devices that are on layer 3 are routers, for example, and layer 2 is switch. This security solution provides both a personal and enterprise mode. A personal mode requires no authentication server and uses a pre-shared key configured on clients and APs to authenticate. It also uses the temporal key integrity protocol for encryption. So a pre-shared key is basically, it's a key which is just a string that you would put on both devices. That's what pre-shared means, is you would share it so that they know each other's keys, and that's what allows them to authenticate. Enterprise uses an authentication server to generate keys or certificates, so that one's not pre-shared, it's generated and gives them out. Next security and encryption method that I want to talk about is Wi-Fi Protected Access version 2, WPA2. This is an 802.11i security solution, and it uses the Advanced Encryption Standard algorithm and the CBC MAC protocol. Protocol, which is CCMP. Some more quick checks. I'll go through these real quick. And now we'll go over some common wireless network protocols. These are going to cover your Wi-Fi numbers, your IEEE protocols, that kind of thing. So first, I want to go over Wi-Fi. This is the WLAN protocol that uses the 802.11 family of specifications. WiMAX. This is a wireless metropolitan area network protocol that uses the IEEE 802.16 specifications. Then you have cellular networks, 2G through 5G. And you have Bluetooth and other WPAN protocols such as Zigbee, IRDA, IEEE 802.15, and so on. These are not covered in depth here. We saved those for the mobile devices lessons and the wearable devices lessons, but I wanted to include them here because they are common wireless network protocols. So now we'll go into some common IEEE Wi-Fi standards. The first one I want to talk about is 802.11. This is a now obsolete Wi-Fi standard. It was the original Wi-Fi standard. And it supported speeds up to 2 megabits per second. They operated on the 2.4 gigahertz frequency range, which now is very overcrowded and can create a lot of interference and slower speeds and just overall not as great performance. Typically, later letters are newer, so you would start with 802.11a, b, c, so on. Also, as the letters increase, they typically provided increased throughput, speed, and so on. 802.11b is one of the most prevalent Wi-Fi standards, and it operates in the unregulated 2.4 gigahertz frequency range, and that explains why there's so many devices in 2.4. It's unregulated, meaning any device can join, or nearly any wireless device can join for any reason, doing whatever traffic they want to do. It's wide open, so a lot of devices operate on that. Maximum speed of this standard is 11 megabits per second. 802.11g uses the same frequency as 802.11b and increases the speeds up to 54 megabits per second. 802.11a uses the 5 gigahertz frequency range and is capable of speeds up to 54 megabits per second. 802.1x is a holding category for standards that are in development but not yet approved by IEEE. So now we'll go over what the Wi-Fi numbers are and how they're associated to the given standards. Wi-Fi 1, established in 1997, is assigned to 802.11. It supports speeds up to 2 megabits per second and uses the 2.4 gigahertz frequency range. It specified 3 physical layer technologies to reduce interference: direct sequence spread spectrum, frequency hopping spread spectrum, and diffuse infrared. More information about these 3 technologies can be found in the link in the documents on the Google Drive or in or Google searching. Wi-Fi 2, established in 1999, was assigned to 802.11b. It didn't introduce many new things, but it did increase the speed to 11 megabits per second, and it also used the 2.4 gigahertz range. Wi-Fi 3 is assigned to 802.11a and supports speeds up to 54 megabits per second. It uses the 5 gigahertz frequency range, which is a new band which reduces interference and range. It reduces interference and range, meaning that because 5 gigahertz is a different wavelength, it actually travels not as far, at least with good quality. Wi-Fi 3 also introduced the orthogonal frequency division multiplexing, which basically allowed many signals over one medium. Wi-Fi 3E, introduced in 2003, was assigned to 802.11g. It supports up to 54 megabits per second and uses 2.4 gigahertz. This is the first standard that introduced backwards compatibility, so that's why a lot of times you'll see in a device that supports Wi-Fi 3E, you may see Wi-Fi supports 802.11b/G or whatever backwards compatibility there is. Wi-Fi 4, established in 2008, was assigned to 802.11n. It supports speeds up to 600 megabits per second and uses both the 2.4 and 5 gigahertz frequency ranges. It added support for multiple input, multiple output antennas, which allows for multiple antennas to communicate with multiple devices, and also utilizes multipath propagation to increase capacity. That's a lot of technical jargon. Again, if you want more information on that, there's links and resources posted in the Google Drive, and a simple Google search should also find you the answers you need. Wi-Fi 5, established in 2014, is assigned to 802.11ac, which builds on 802.11n. It supports speeds up to 6,933 megabits per second and uses the 5 gigahertz frequency range. Wi-Fi 6, which was introduced in 2019 and isn't widely available yet, was assigned to 802.11ax, which builds on 802.11ac and supports speeds up to 9,608 megabits per second and also uses the 2.4/5 gigahertz frequency ranges. Wi-Fi 6E, which also isn't widely available yet, was also introduced in 2019 and is also assigned to 802.11ax. The speed is the same, up to 9,608 megabits per second, but it introduces a new range, the 6 gigahertz frequency range. This is some more quick check. Now finally we have the lesson summary. The lesson summary goes over a few of the key points from each topic. I'm not going to go over it here because we just went over it. But again, these slides are available on the Google Drive, and the video is available on my YouTube page if you want to check it out. And then finally, you have the final assessment, which reviews the entire lesson and is just there to check the student's knowledge, make sure that they got the key points out that they needed to get. And these are some references that we used. So that's it for that document. The last one I want to show is some of the hands-on activities. Again, I'm not going to go through these in detail just because they're available and there's a lot to them, but I do want to go over them briefly. I'm going to take a break real quick and get a sip of water. I will be back shortly. All right. We're back, and I need to switch over to the window capture or a display capture I need so that it will show my Word document, because it's not going to show it otherwise. There we go. Alright, so last thing I want to go over a little bit today are some of the hands-on activities that we created for these lessons. Again, we're using lesson 1 as an example. And so for the hands-on activities, you have your 3 hands-on activities listed here. And then you have the title and the estimated time to complete each hands-on activity. The background section just covers kind of what the activity is, what it's doing, why it's doing it, the purpose, that kind of thing. So for activity 1, this is a case-based activity where you have to read through a particular case that a client has or a customer has and identify the needs that they have, and based on those needs, what network best suits them. So this particular activity is important because in the IT workforce, oftentimes you have to understand a client situation or customer situation and be able to deduce what solution best suits their needs, or what solution best solves their problem based on the needs that they say, and sometimes what they don't say. Sometimes you have to infer a little bit. So after the brief background that explains the importance and what you're doing and why you're doing it, you have a brief setup instructions that kind of tells you how to set up, how to prepare for the activity. And then you actually get into the instructions for the document. So for hands-on activity 1, the case 1 is Jan runs a small business out of her home where she hand makes bowls that she then sells online. She has approached your company because her current network is not suiting her needs. Connectivity works fine inside the home, but diminishes significantly in her workshop. She also needs to remain mobile so she has access as she moves to different areas of her shop. And then you have your questions, which would be provided to the students. The answers wouldn't, obviously, but the questions would be provided that kind of help the student know what to look at, where to be thinking, where to put their line of thought to answer the questions. So question 1 says, what type of wireless network best suits Jan's needs in case 1? In this case, she's going to be looking at a WLAN because she's in the home. She needs wireless access within one building, and it's a relatively small area. Question 2 says, should Jan make her entire network wireless or use a wireless extension off the wired portion? Why, and what hardware would you recommend? So for this one, answers can vary, but in most cases, a wireless network or a wireless extension is likely preferred since she's not having connectivity problems inside the home. This will allow for the benefits of a wireless network where she needs them, but also allow for the benefits that a wired network provides where it's already working. Suggested hardware that they may list are wireless routers or access points. The next case talks about PD Digital, which is a global digital marketing company. They have offices around the globe, and recently they've been experiencing issues such as information silos, where one office has information that the others don't have access to, and other miscommunication problems. Many employees at the firm believe this is because they do not have an easy way to communicate or connect with each other. They are looking for a solution that will address their needs for shared access across all offices without going through the process of seeking out someone who can send it to you. So again, you have to use context clues here. They're a global company. They want to be able to communicate wirelessly. So automatically you should be thinking wireless wide area network. In case 3 is a little different. You have XYZ organization, which wants to help secure business and government networks and assists in responding to attacks. The amount of sensitive data that they must protect is large and crucial to the operation of its clients, and the organization requires a quick response time to be most effective. When they began as a startup, they opted for a wireless local area network due to the clients were limited. However, they have recently started noticing a decrease in reaction times as well as more security events. What network type best suits the organization's needs? In this case, we chose a wired network, specifically because they said they need reliable, constant access, as well as the best speeds possible and security. So in this case, we chose a wired network. The next question asks, why would a wireless network be preferred in this case? Again, because they need security and speed benefits. A wired network can provide better security and speed overall. Question 3 says, is it worthwhile for the organization to maintain both their wireless and wired network portions? What benefits could this bring? Again, answers can vary. This one is very open-ended. Some people may think it's less beneficial. Some people may think it's more beneficial. I personally think it's beneficial to keep both because you can experience the benefits of both where they're needed. You have the wired network where the most secure data is, and the wireless networks in the areas where not less security. You want all your stuff to be secure, but the wireless networks where mobility is more optimal, and you can maybe deal with a little bit of a lesser security, such as HR or finance, maybe. Just those are just examples. Those are just ideas. Again, that's a wide open question. There can be so many answers to that one, and there's no correct answer. So after each activity, there's a few review questions that kind of go over the key topics of the activity. They review what the key topics are, what the key takeaways are. I'm not going to go through those right now, but I will read the questions. Question 1 is, what qualitative characteristics of a company may impact the solution? 2 is, what quantitative characteristics may impact the solution? Number 3 is, why is it important for those in the IT field to be able to identify the needs and best fitting solution for a company? And finally, number 4 is, it asks, what is a scenario where it makes sense to go entirely wireless rather than having a mixture of the two? That's hands-on activity 1. Hands-on activity 2 and 3 are much more hands-on, much more involved with the devices, and they both use a program called Packet Tracer, which is a free network simulator offered by Cisco. And with it, the students are tasked with setting up a small office, home office, wireless network in activity 2. And in activity 3, they're tasked with identifying where there's an error in the network. And activity 3 focuses on understanding the path that a wireless packet takes and establishes some fundamental troubleshooting steps, which are important in the IT field because you'll always be troubleshooting. And in activity 2, it teaches how to set up basic wireless network, which is a skill you can use both in and out of the IT field. So again, I'll just go through a brief overview of what these hands-on activities look like. So again, you have the background. This particular background explains why the project is important and introduces Packet Tracer. You have the setup instructions, which in this case are setting up Packet Tracer. And then you have the actual hands-on instructions, which are kind of a step-by-step of how to do it. Sometimes they're left a little open just so that students can think through it, but the answer is eventually given in case they get stuck. And the same thing in the videos. The videos are there to not only help the student get more from the activity, but to help them in case they get stuck. So you're setting up the wireless router, setting up the wireless clients, configuring a wireless access point, setting up another wireless client, and verifying connectivity. Then again, you have more review questions going over what the Packet Tracer represents, what the lesson was, what the key takeaways were. And finally, in hands-on activity 3, again, you have the background, the estimated time to complete, the setup instructions, and then the instructions for the actual activity. So for part 1 of the activity, you have to identify the path of a packet. You're looking at what path a packet takes, how it traverses through the network, and then answering a couple questions about that. And that introduces the ping command, which is essential in troubleshooting ping and trace route as well. And it also introduces the simulation feature in Packet Tracer rather than the real time. In simulation, you can drop a packet on the network and watch it traverse and actually watch it go across the network. In part 2, we're identifying where there's an error in the network by using basic troubleshooting steps like ping, trace route, looking through configurations, that kind of thing. And you're identifying where the error is, documenting that, documenting what the error is, and documenting how you fixed it. Again, all of that is given to the students towards the end of the activity in case they are stuck. But we really want them to be able to think through it first and try to get to the answer on their own. And if they can't, come back to the video, come back to the activity. Again, you have more review questions. Each activity has about 5 to 6 review questions. And that concludes the presentation. That was an overview of the lesson. That was an overview of the project, an overview of the lessons, particularly lesson 1, an overview of the hands-on activities. Are there any questions anybody has? While I resize my camera. Does anybody have any questions, comments, or concerns? Anything they want to say about the project? It's looking like no. It's looking like everybody's good to go. So in that case, I want to thank everybody for coming. This video will be available on my YouTube page for the foreseeable future. So if you missed something or you want to go back and look at it again, feel free to go take another look. Thanks everybody for coming, and I appreciate you checking it out.